Hello, you see this question? Many will not know how to go about start solving this question. Look at the expression, they don't have a common base. So how can we find the values of s? Can you solve this? Pause this video a little and try it and let's see how it works for you. If it does work, then you can start this video and then see how we'll solve it together. To solve this question, I suggest we should take the logarithm of both sides, or better still, the natural logarithm of both sides. Now let's start with natural logarithm because I love working with the natural logarithm. Now if I take the natural logarithm of both sides, I'll have the in of 3 to the power of x equal to the natural logarithm of x, right? Now in the next step, remember the laws of logarithm. The x will come over to multiply the logarithm and then I'll have x multiplying the natural logarithm of 3 and this will be equal to the in of what? Of s. Now what do I do from here? From here, I'll have to divide both sides by 3 by x. If I divide both sides by x, you come to see that over here, x will cancel out x, and then I'll have the in of 3 to be equal to the in of s divided by s. So in the next step, what I'm going to do, we're going to see how we can simplify this. Now in the next step, I'll have the in of x divided by x to simply be equal to the in of 3. We have not changed anything. So at this point, I want you to recall some exponent expression. If you recall this exponent expression, you agree with me that the exponential value of in of x can simply be equal to x, right? So how do we apply this? We're going to replace that with this. So if I replace that with this, I'll have the in of x divided by the exponential value of the in of x, and this will be equal to the in of 3. Now in the next step, I'll simplify further. If I simplify further, all I will need to do is to break out the expression. I want you to recall this, that if you have 1 divided by a to the power of x, this can simply be equal to a to the power of negative x, right? Because this expression 1 over is represented by negative x. So this expression will now give me the in of x multiplying the exponent of the negative value of the in of x, and this will be equal to the in of 3. Good. Now in the next step, I want us to do something, because if we don't do that, this expression will remain like this and it will not look like the Lambert W function expression. Now what do? Let us multiply both sides by negative. If I multiply both sides by negative, I'll have the in of x multiplying the exponent value of the negative of in of x, and all of these will be equal to negative of in of 3. Now this expression will give me the in of x, negative in of x multiplied by the exponent value of the negative in of x, and this will be equal to the negative value of the in of 3. Now if you look at this expression properly, you see that the multiplicand is equal to the power, right? Negative in of x and negative in of x. Now, this can look similar to a Lambert W expression. Do you recall this Lambert W expression? Now, we have the Lambert of this expression, a multiplied by the exponent of a, that the result will simply be what? Be a. Now, if we apply that here, we're going to see that if we take the Lambert of both sides, we have the Lambert of the in of the negative in of x multiplying the exponent of the negative in of x, and this will be equal to the Lambert of negative in of 3, right? Now let's simplify that expression. If we simplify this expression, all of these will simply give me the negative in of what? X according to Lambert expression, and this will be equal to the Lambert of the negative in of 3. Great. So how do we simplify this? We're going to simplify this by taking both of them back to an expression that is similar to an exponential value. But before we do that, let's multiply both of them by negative. If I multiply both expressions by negative, I'll have negative multiplied by negative in of x, and this will give us negative the Lambert of negative in of 3. Now, why do we do this? We did this so as to easily simplify the left hand side. Now, if we simplify, negative multiplied by negative will give us the in of x, and the in of x is equal to negative the Lambert of negative in of 3. So what do we have here? What we have here can easily be simplified, because you recall that the in of x can be equal to x. Now remember this expression. So if the in of x, the exponent of the in of x can be equal to x, if we have that expression, what we need to do is to simplify. And if I simplify, I'm going to take the exponent of both sides. So if I take the exponents of both sides, I'll have the exponent of the in of x equal to the exponent of the negative of the Lambert of negative in of 3, right? And remember this expression. All this expression is simply going to give me what? So my s is equal to the exponent value of the negative of the Lambert of negative 1 in of what? Of 3. Does that look like a solution? Of course, it looks like a solution, but we can simplify this further. If x is equal to this, I want you to recall that if I have a to the power of negative x, this can simply be equal to 1 divided by a to the power of x. So if I simplify that expression, I'll have my x to be equal to 1 divided by the exponent of the Lambert value of in negative in of what? Negative in of 3. And this serves as the solution to that mass expression given to us up there. So you see, the solution is simply a complex what? It's a complex solution and not a real solution. So that's the solution to this mass expression given to us up there. I know you did enjoy watching this math solution. Don't forget to give it a thumbs up, share with friends and colleagues, and remember to subscribe to my channel. You can also give us a super thanks we truly appreciate what we're truly doing. We really appreciate your contribution toward the growth of our channel. Thanks so much for watching, and bye bye for now.